The goal here is to show the simplest way possible to take a Raspberry Pi from scratch with nothing on an operated, bare SD card, and turn that into running a Amazon voice service, also known as Alexa, sample program so that you can actually talk to your Raspberry Pi and have it run voice recognition out to Amazon. I have another talk where we do this with AIY, Google AIY voice hat. This is a totally stock machine that I'm going to do this on. We're going to use just a powered speaker plugged into the audio out jack, and we're going to use a Logitech microphone. In this case, it's just an old Rock Band mic. So the Rock Band mics are actually recognized by all the major operating systems as USB mics. And I need a mic for the Raspberry Pi, and it turns out this thing works with no work. So the total of this is about 15 minutes worth of work, and then about 3 hours of letting it compile the entire AVS code from scratch. And then you compile and it runs the sample program. And then after that, you just got to build the sample program as you make changes or build your own program. So this is actually pretty straightforward stuff. We're going to download a PiOS image. We're going to image that onto an SD card, stick a card into the machine, my laptop, in this case, Windows machine. We're going to eject the card after it's been imaged and reinsert it. That'll get it mounted. And then we're going to run the Ethernet gadget PowerShell, which is poorly named. It'll probably be changed sometime in the future. That's this thing over here on the left. Basically, we run the Ethernet gadget PowerShell. That actually will enable, without having run it yet, it's still in the Windows machine, it'll enable SSH. It'll enable the Wi-Fi connection if you give it a username and password, and it will copy a bunch of scripts to the boot partition on that SD card. And then if it's a Pi 0, it'll actually enable the USB Ethernet gadgets. You eject the card, we put it in a Pi. Oh, sorry, wrong scroll bar. We put it in the Pi, and we boot the Pi on the new card. We SSH into Raspberry Pi.local, and then we run these two scripts, which were in /boot. Hostname, we'll give it a custom hostname that is equal to the serial number. It'll be pi-serial number.local. And then we're going to run the firewall. That actually, we have SSH enabled. What it'll do is it'll disable it on any wireless connections, but it will enable it on any wired connections. So that way you can plug back into the backside of this or on your hardwire network. If you need something more than that, because you're actually going to put this out somewhere, then you would have to tighten down the firewall. But I basically did this so nobody could jump onto this thing from over a Wi-Fi connection, but it would still be able to use a Wi-Fi connection to have access to the internet, but I would be able to just jack onto a hardwire connection with it. In this case, we're not going to do the air hack piece. We're just going to, we want AVS. So if we run the AVS Smart Screen setup script, that will basically install everything. The only caveat for this, which you'll find in the MD README file, is that we have to, you gotta go enable AVS on your account. You gotta get a token, a JSON file to put in your home directory on the Raspberry Pi. And then you run this setup script. It will download and build everything. And then you run this run script and it will verify and bring up Alexa for you. I'll just show how that part works. So again, that's why we have the flowchart. You basically just image it, drop a bunch of crap on it, boot it up. It'll be on Wi-Fi. Then you run this, register your stuff with Amazon, and then you run the setup script from the boot partition. It will download everything and compile it for you. That takes like 3 hours and on a Raspberry Pi 3, and then you can, it'll run it, okay? So I'll just show you. In this case, this is a stock system. So yeah, card 0 is, actually turns out to be the headphone, right? And card 1 in the plug-in system is the USB mic. If I were to unplug the mic, this card will go away. The run script that comes with this run script right here, or if we're going to the repo, you can see it here, right? It'll be this one here, the setup and the run script. The run script will automatically configure the asoundrc file so that you are plugged in correctly. And you can see here that it actually knows my Logitech is card 1 and the sound audio jack is card 0. And I can show you this works. So if we just, I'm sitting here, I can go /boot /AW. Oh, bash, my bad. Bash /boot /A. Alexa, set up. Nope, don't want to do that. Don't want to compile it. Let's just going to run it after it's already been built. I have the wake word enabled. That's actually up to you. There's a switch that you can either do hardwire, buttons, or... So in this case, I'm going to say, Alexa, what is the weather today?
North Potomac, it's 58 degrees Fahrenheit with mostly cloudy skies. Today, you can look for partly sunny weather with a high of 59 degrees and a low of 39 degrees.
There we go. And then we can quit that, and that's the end of that. So that's it. You just basically run those, follow the flow chart, register your stuff with Amazon. You'll be able to play with the AVS services, super simple, on a Raspberry Pi 3 in this case, but you can use other units.